All right. So aloha, everyone. My name is Kapehe. You can call me Cap. The full name actually is Kapehe Okaleni. Kapehe is the short version. Cap is the even shorter version. So either one. It means the cry to the heavens. It's Hawaiian and it's a family name. So it means a lot to me. So today I will be speaking on the battle of house promises versus house observables. So have you ever wondered what it would be like if observables and promises got into a room and battled it out? So that's exactly what we're going to be doing in this talk. So before, let me introduce myself again. My name is Kapehe. I am from Las Vegas, Nevada, and that's actually where, like we said, Ben and I met at the other RxJS Live conference. And a lot of the other speakers were there as well. I do developer relations at Sanity. It helps manage your content for your website. And I'm also the mama to 5 animals. So let me introduce you to my animals real quick. So we have Polly. She is part Siamese and the ultimate lap cat. We have Hilo. She is part tabby, they say. And she loves treats so much. All you got to do is crinkle the bag and she'll come running. And then we have Bella. If you have seen some of my videos on Twitter, she is the star of the show. So I got her that little medal. And then I have 2 bunnies, Bonnie and Clyde. They're brother and sister, and I got them from my sister. They're 5 months old right now. So those are my 5 kiddos. All right, so before we begin, we're going to play a quick little game of Would You Rather. So would you rather fight 100 Aria-sized hounds or fight 1 hound-sized Aria? So I don't know about you, but I would probably pick the 100 Aria-sized hounds because I wouldn't even fight Aria in her normal size. So she's pretty tough. And as you can see, this is very Game of Thrones themed. So hope you enjoy. All right, so let's talk real quickly about JavaScript promises and RxJS observables. So a promise is an object that produces a single value asynchronously. So promises are very eager. And so if you had a callback function promised to or provided to a promise, the function is executed immediately in the .then. So super eager. So the question is, are we wasting resources with that eagerness? Now, observables are able to emit multiple bits of data over time. So you get that stream of data. Now, to create an observable, you create a function, and this function will return our data. They are very lazy, so opposite of promises. So we'll need to subscribe to it before we can get what we need. So is this more efficient? We'll see. But that's promises and observables. All right. So we have 5 grueling battles for you in this promises versus observables fight. So battle number 1 is going to be looking at simplicity. All right. So promises come built in JavaScript. So there's no need to add any third-party library. The package size of promises is 0, nothing, zilch. It just comes built in. So we don't need to add any dependency, nothing to get them working. They just are there. Now, observables are a part of the RxJS library. Now we have to add a third-party dependency. So there's this great website called bundlephobia.com, and it will tell you how large a library is. So let's see the size of RxJS. So we went here, RxJS, hit enter, and it looks like 45.6 kilograms. All right, or kilobytes. It doesn't seem like much, but every byte counts when we're talking about performance. So that poses the next question. How much data are we talking about? So promises and observables are both very powerful. Both can get the job done. So is adding an entire library needed? What if we only have a small amount of data? So how much data? Small amount, minimal processing. Let's just use a promise. It'll keep the project lighter, and there's no need to bring in the entire RxJS library. So battle number 1 goes to promises for its simplicity. All right, battle number 2. in this exhausting battle, we're going to go over unicast and multicast. So unicast, let's go over that one first, is a one-to-one communication process. Multicast is a one-to-many, so lots of different people it can go to. Now, how does this work in the world of Game of Thrones? Let's visualize this. So let's start with multicast. So the crowd favorite is Jon Snow. We all love him. He is such a fair leader. He wants to make sure everyone gets the same message. So we have the 3 houses that he wants to tell that everyone is safe. He wants to send that same message to all of them. So when he spreads his message to all of them, he is multicasting. So one to many. Now, unicast, Cersei handles things in a unicast way. So she is going to promise something different to each house. So we have our houses. This one gets 1,000 coins. This one gets freedom. And this one gets to rule the kingdom. So a way I like to remember it is unicast is actually unique cast. Every single person gets a unique bit of data. So promises are multicast because of their eager nature only, whereas observables are multicast and unicast. So by default, observables are unicast, where every result will be passed to a single unique subscriber. So with all that being said, I'm going to say battle number 2 goes to observables for giving us a choice on multicast or unicast, whichever one we want to use. All right, so battle number 3 will be fought in the functionality battlefield. So to demonstrate, we are going to look at 2 different examples. So let's look at grabbing information from an API. We'll look at a promises example and an observables example. So the promises way, we're going to be doing the exact same thing with both. So we'll need to grab data from an API, and we're using the fetch. So since we are using JavaScript fetch, we need to unwrap it. And now that we have the characters, we'll finally use them. And as is tradition with George R.R. Martin, what are we going to do with them? We're going to kill them off. So remove from show. Let's not do that to all of them. Let's only remove the characters that have an allegiance to one of the great houses. So we have to filter. Now we have async await as well. So we can remove the .thens if we want to use that syntax instead. So now this is where it gets complicated. We want to get another API call to get the information about the house they're allied to. Okay. Now putting all of this together, our example gets long and kind of hard to follow. So we've done 3 things. We've grabbed a list of characters, we've filtered a list of characters, and we got new data for each of these characters. And he's not happy about the length. So let's look at the observables way. So we are going to use from fetch to get data from the API. We are going to use switch map to unwrap the data. Next, we are going to filter out the characters with an allegiance. And since we need to go grab a new set of data from another API call, we're going to merge map so we can combine these 2 sets of data. Finally, our map is where we combine our 2 bits of data. And putting it all together, we get a more concise function that we can easily add more logic to without having to write much more. Now, if we really wanted to, we could also do this type of way with promises, but we could create the functions outside of the observable and make it even cleaner. Now, the thing that I really want to point out here is the power of the operators. So without having to write all the logic out like we would have to with promises, observables give us operators that do the magic for us in a functional way. Nice. All right, so with all that being said, battle number 3 goes to, drum roll, observables for being a little more readable, allowing us to create less code and having those nifty operators that we can use. So it's 1-2 right now. Observables are in the lead. Okay, battle number 4 will be fought to prove their ability to cancel. Okay, so promises straight up are not cancelable, at least not naturally. So there are many ways to cancel a promise. You can use another promise to cancel your first promise, but now we're just writing extra promises. So that's where a nifty little package comes in called bloober.js, a third-party library that helps us cancel promises. Okay, but to be fair to battle number 1, let's pull up Bundlephobia and see how many kilobytes bloober.js is. Okay, so 76. That's almost double what RxJS library was. So that 0 kilobyte thing kind of it's kind of irrelevant now. But yeah. Now with observables, they have been designed to be cancelable from the beginning. So there are many ways to cancel an observable, one being to simply unsubscribe from it. So you may have seen this scene. Let me pull it up. You may have seen the scene where the Night King raises the dead. What you don't know is that he's using an observable. So we have the Night King and his 4 minions. And as soon as we destroy one of the minions, they will actually subscribe to the Night King because they need him to come back to life. Then whenever he goes to raise the dead, they get the information, they're raised from the dead, and then they unsubscribe because they don't need him anymore. So let's watch that one more time. They wake up, they don't need him anymore, so they unsubscribe. And when they die again, they will subscribe back to him because they need him. Thanks, Night King. All right, so basically, this is what his minions are doing in code form. So they will subscribe to him when they need to come back from the dead, and they will cancel and unsubscribe when they don't need him. So battle number 4, I'm going to give it to observables because of their cancelability. They make it easy. All right, so we have one more battle. This battle is going to be looking at how promises and observables handle 2 tasks that are racing to complete first. So this could be an API going to get data. So yeah, 2 tasks racing each other. Which one finishes first and how does it handle that? So let's talk about promises. Like we talked before, promises cannot be canceled. Because there's no cancellation, we can find this a problem when it comes to racing. So if we were to look at a win-lose situation, promise.race will take on a bunch of promises and continue to execute all the promises, whether they win or lose. And by default, the side effects that come with it. So maybe the purpose of our race was to save loading time and we only wanted the first result back. We could be wasting time and resources by waiting for all of them to finish. So the first one will finish and we'll get that information back because that's what we want. But those other ones will end up finishing in the background. So that may slow us down a little bit. On the other hand, observables also have race. So let's look at an example of promise.race and observables race. All right, so promise.race. This takes in 2 different promises, a fast one and a slow one. So we see that there are many things that should be considered. The first promise is a fast one. So we should see dragon being displayed, and then immediately after, we should see fire. Second promise is slower, so it loses the race. This promise, console's dungeon. But because we couldn't cancel the losing promise, the dragon is stopped, and we end up with the dragon now in the dungeon, unable to keep Daenerys safe. And we don't want that. So even though dungeon lost, it still was consoled. So the result of this promise.race would be dragon, fire, dungeon. So let's look at that code again. Dragon goes first, then fire, then dungeon. So it goes in order, but the slow promise wasn't canceled. So we get all 3 of them returned. Even though dragon is first and that's what we wanted and we can move on, the others still resolve and finish. Now the observables way. In RxJS, we have the race method. So let's look at that code. So the first observable to be emitted is the winner. The loser never even gets a chance because of cancelability. So if we were to use race, our first observable would console dragon and fire. So we want the dragon to stay strong and have his fire breathing ability so he can keep Daenerys safe, right? So if the slow one ran, we would run into the same issue with promise.race. The dragon would be in the dungeon and we wouldn't be able to, or the dragon wouldn't be able to protect. So the observable that lost in the race is canceled and we don't need to see what it would have done because the winner is what we wanted. It's canceled before it even gets to the slower one. So the faster one is the one that we wanted. We wanted the dragon and the fire. So our final output would be, for this one, dragon and fire. The slow one would just be canceled and it wouldn't even end up processing. It wouldn't even be able to resolve itself. So battle number 5, I'm going to give to, and you can probably all guess, Observables for its ability to use race and cancel everything else that loses to the winner. So we want to keep our apps as fast as possible, right? All right, so we did our 5 battles. Let's talk about the winner. Okay, so before I do have a very exclusive clip for all of you. I got permission from George R.R. Martin himself to share it here. So the clip is from the unannounced season 9 of Game of Thrones. So please, everyone, let's keep this top secret. No spoiler tweets. Let's enjoy. And I hope the audio is on here.
Turn around! Back! Back! Fire!
Okay, so it looks like observables actually do come out on top. So, okay, but in all honesty, after looking at those battles, I would have to declare that observables do win in the end compared to promises. They allow for more functionality, the ability to be canceled, and I think the huge one is operators. They're so nice to have. So, but sometimes promises are the way to go, and it's important to understand which one to use for your project and which one would benefit your certain case. So, mahalo everyone for coming. Thank you for joining all of us today. You can find me on Twitter at Kapehe_OK, and I'll follow suit. Mahalo.